All right, let's dive into one of the weirdest, most fascinating ideas in all of science, quantum superposition. It's a concept that basically takes the rulebook for our everyday reality, throws it right out the window, and shows us a world that is just wonderfully strange.
So to get our heads around this, let's start with something really simple, a coin toss. You know how this works. In our world, a coin lands and it's either heads or tails. Simple, right? One or the other, it can't be both. But in the quantum world, a quantum coin doesn't have to choose. It can literally be in a state of being both heads and tails at the exact same time.
And right there, that's the big question, isn't it? How is that even possible? It feels wrong. It goes against all our common sense. But for the tiniest building blocks of our universe, this is just how reality works. So let's try to unravel this mystery.
Okay, to understand this, we gotta learn the rules of this strange new game. We're going to define what superposition actually is and get into the principles that make it all happen.
So what that really means is that a tiny quantum system, like a single electron or a particle of light, exists in this kind of blended fog of all its potential outcomes, all at once. It's not heads or tails. It's a probability cloud that contains both.
Now, this is absolutely crucial. We're not just talking about something being hidden from us. It's not like the coin has landed and we just haven't looked yet. No, in the quantum world, the universe itself literally hasn't decided on an answer. The property is genuinely, truly undetermined. It's just a state of pure potential.
So, why does this even happen? Well, a big piece of the puzzle is that quantum objects aren't just tiny little balls. They also behave like waves. Imagine dropping two pebbles into a pond. Where the ripples meet, they can add up and get bigger, or they can cancel each other out. Superposition is kind of like the quantum version of that. It's the result of all these waves of possibility interfering with each other.
Okay, so if everything's this big, blurry cloud of all at once, why does my world look so, solid and definite? This is where an idea called wave function collapse comes in. And it's good to know this is just one interpretation, but it's a popular one. The idea is the moment we look, the moment we measure a quantum system, we force its hand. We make it pick one. That whole cloud of possibilities just vanishes, and the system collapses into one single solid reality. The simple act of looking changes everything.
All right, that's the theory. Let's see how this plays out in some really famous examples. Because this isn't just some abstract idea. Scientists have seen these bizarre effects in some legendary experiments.
You've probably heard of this one, right? Schrödinger's cat. Now, this was a thought experiment, not a real one, and it was designed to show just how absurd this whole idea seems. If you link a cat's fate to a random quantum event inside a box, then according to the rules, until you open that box to check, the cat isn't alive or dead. It's in a superposition of being both simultaneously alive and dead.
Now for a real-world experiment that is just as strange. It's called the double-slit experiment. So imagine shooting tiny particles, like electrons, at a screen with two slits in it. If you set up a detector to watch which slit they go through, they behave exactly like you'd expect. They act like tiny little bullets, going through one slit or the other, and making two clean lines on the wall behind. Makes sense, right?
And this is where it gets completely mind-blowing. If you run the exact same experiment, but you turn off the detector, you stop watching. They stop acting like particles. They start behaving like waves. They go through both slits at the same time, interfere with themselves on the other side, and create this complex wave pattern on the back wall. The simple act of not looking fundamentally changes their behavior. It's wild.
So you might be thinking, okay, this is a fun, weird, philosophical puzzle. But superposition isn't just a curiosity. It's incredibly powerful, and it's at the absolute heart of a massive technological revolution.
Everybody, meet the qubit. You see, the computer or phone you're using right now runs on classical bits. A bit is simple. It's either on or off, a 0 or a 1. That's it. But a quantum bit, a qubit, it harnesses the power of superposition. So it can be a 0, a 1, or, you guessed it, a combination of both at the same time.
And that difference, that both at the same time thing, that is everything. A classical computer has to check possibilities one by one, sequentially. But a quantum computer, because its qubits can be everything at once, gets to explore a massive number of possibilities simultaneously. It's like instead of trying one key at a time to open a lock, you get to try all the keys at once. The jump in computing power is just staggering.
So what can we actually do with that kind of power? We're talking about solving problems that are currently impossible for even the world's fastest supercomputers. Things like designing brand new medicines molecule by molecule, creating new forms of artificial intelligence, and developing truly unbreakable codes to protect our information.
The potential is just immense.
Okay, so we've journeyed from a quantum coin all the way to world-changing technology. But let's zoom back out for just a second and bring it back to the big picture. And one final, profound question about what this all really means.
So if there's one core idea to take away from all of this, it's this. The fuzzy, undefined world of quantum potential becomes the solid, certain world we all experience through the act of measurement, of observation. Our very interaction with the universe seems to be what forces it to go from a set of possibilities into a single reality.
And that leaves us with this incredible, lingering question that physicists and philosophers are still wrestling with. If our observation is what solidifies reality, what is the true nature of the universe when we aren't there to look at it? Something to think about. Thanks for joining me on this one.